Okay, so today we are going to discuss another type of version controlling systems. There are typically in the market two types of version controlling systems are there. Now I need to explain you what do you mean by version controlling system. So it's typically a source code management tool which manages your source code and maintains a history and enables some security, okay, which allows you to do some sort of branching, okay. So that tool we call it as a version controlling system, right? So typically we use version controlling system to store the source code. So there are two types of VCS tools. One is client server based, okay. So client server based VCS tools, right? And another is distributed VCS tools, okay. So now the client server based VCS tool is an example. It's a two-tier architecture version controlling system. The example is CVS and SVN, whatever you have gone through in the last couple of days, right? This is a client server based version controlling system. What exactly the meaning of it is, every developer will be trying to connect to the one server repository, okay, and they try to push the code and they try to pull it it's a two-tier, everybody will be pointing to one centralized repository. So that's how it works, okay. And CVS also works in the same based, okay. There will be a centralized repository and people will be connecting to it, okay. Then we have one more type of version controlling system, which is a distributed, okay. This is also called DVCS. So somebody may ask you, do you know any DVCS tools? Okay, so DVCS is nothing but distributed. So what do you mean by distributed is, let me try to explain you with an architecture, then you can understand much better. What is the paintbrush? We have this. I think this is not required at the moment. Let me save this diagram. SVN. Oops. Okay. Okay, new diagram. So I'm just trying to compare, show you both the tools, how they look like, okay. This is your typical version controlling system, which is server centric one, the client server based one. You will be having one server and you can have n number of clients, okay. And this will work always in an online mode, okay. What do you mean by online mode is, see, you should be able to reach the repository, this server, okay, SVN server, then only you can push your code and you can pull the code, okay. That's how it works. This is the first type of version controlling system, okay. Just keep this aside. And there is one more type of version controlling system, okay, where you will have a centralized repository, okay. You will have a repository, centralized repository, but at the same time the developers who are working, okay, they will have internally one repository in their machine, okay. In their machine they will be having another repository, and this repository is a cloned copy of, assume this is what your main repository. So the main repository hosted on some server, okay, and this we call it as a, you can call it as a origin or main repository, anything is fine, main or origin repository, okay. Now all these developers, what they are supposed to do it, they will clone this into their local machine, okay, and they'll be having a replica of that origin, okay, and they have the same repository and everybody will be having the same repository. So when I say repository, nothing but it includes everything, all the branches, tags, everything, all the stuff, okay. It's not like a particular branch or particular tag and all. See, in SVN it's not the case. You can choose whatever the path, whatever the branch you want, but here in this distributed version control system you don't have a choice of getting a particular file or a particular directory or a particular branch. You have to get the entire repository in your local machine, okay. So once you get it, once you get that right, now you will be working on your area, which this is your machine, C drive or D drive, whatever it is, okay. Okay, your C drive, some workspace, okay. So you'll be working on workspace and you will push your code to your local repository, okay. So you will be pushing your code to your local repository. So let me put some sort of arrow mark, okay. And, right, so this repository we call it as a local repository. Okay, and you can do n number of times the, pushing your changes to your local repository. Then you might be thinking, then if there are some changes I pushed into, assume like he's a developer A. Okay, developer A. Now he is a developer B. Okay, B developer. Now if he wants those changes, okay, how can he get those changes? Okay, so the ideal approach is, this guy is supposed to push the changes to the main repository. Okay, so this is not called a pushing, it's something like synchronizing, like you are like replicating, you're pushing all the changes from your local repository to your remote repository. Okay, now what these guys are supposed to do, they have to pull the changes. Okay, see, just by cloning is not sufficient enough, it's something like pulling it. Then you might be a bit confused now. Okay, then what is the difference between the earlier SVN and this? We are doing both the same, right? Only thing is, here we are directly working on it. Okay, so you are directly working over here. Sorry, you are directly working on workspace. Okay, instead of having any kind of a local repository, and you are directly pushing it to SVN server. But only the difference is you have another layer here. Okay, which is a local repository. So any commits which you do it will go to local repository, and when you feel like you want to share your changes to somebody else, then you push your changes to remote repository, so somebody else can download those changes into their local repository and they can pull it into their local workspace, right? Okay, like this. So now you might be having a question, so even this looks like a kind of a what do you call, server centric, right? Client server based. See, I would say it looks like that. Okay, but ultimately the advantage of this kind of a structure is it even allows something like this. Suppose you both are working from home, you don't have a connectivity of your server. Okay, you both of you don't have you don't have any connectivity to your remote repository. Now you want this guy's code. How do you get that? Okay, so that can be easily done if you make use of a DVCS tool. What you can do it, when you're pushing your local repository to remote repository, right? In your configuration, you always point to the remote repository. Now instead of pointing to remote repository, if you're offline nothing but you're not connected to your office network, or you're not able to reach your server, what you can do it, you can push it to, okay, your friend's repository. This is possible only in DVCS. Okay, and this guy can download that. You got my point. And any kind of a workspace to workspace communication which is not possible in your client server version controlling systems. Okay, see, this is not only that. Suppose there is a new developer joined in the company. Maybe like he is still like not having a connectivity to his remote machine. Okay, and he is having an empty box. Okay, now he wants the source code from the remote repository. This is what your main repository, but he don't have access to this. Okay, but to temporarily work with the code, right, what he can do, he can pull from anyone else repository. See, if you have a local repository, you can pull from there and you can have a copy of it. Okay, and similarly this guy can push it to somebody else, right? So as it's like there is no limit, anybody can communicate to anyone. So as there is no like a directive mapping between the the servers or the client to repositories, right? That's the reason this type of architecture we call it as a distributor. Okay, a distributed nothing but there is nothing like one repository we are pointing, or like one-to-one mapping. It can be end-to-end. Okay, you can push it to any server and you can pull it from any server. So that's how it works. But ultimately in an organization, everybody should sync with one main repository that we call as a remote repository. Okay, so whatever is there here, okay, this we call it as a remote or main or origin, you can call it with any name. So typically we call it as a remote repository. Okay, so in an organization, as a DevOps engineer or a build engineer, your job is to set up this remote repository, okay, and ask all the developers, so guys, you clone from here and make sure you synchronize all your local repository with the remote repository. That's how they'll be working it. Okay, so this is what the distributed version controlling system. So when it comes to the features of distributed version controlling system, I can just note down one by one. Okay, so this is mainly like people can work in offline mode. Okay, but in SVN, I mean this kind of a client server base, it should be a online one. you should connect it to the your repository, then only you can work. But here you can work on offline mode as well. Okay, and this is distributed. There is no limitation of like you need to submit your commits only to the repository. You can submit to any other repository. Okay, and one more thing is this is okay. What else? These are the two important things. Yeah, branching and merging is easier in distributed version control system. How it is easier, I'll show you later. Okay, just for right now, try to understand it's a bit easier compared to that. And one-time checkout. Okay, so one-time checkout, nothing but see, when you're working with the distributed version controlling system, you clone your repository, right? It's a one-time. Next time onwards, you need to like check out new branches, new tags and all which was created by here. See, in SQL, right, if new branch is created, you're supposed to check out the new one. New tag is created, you're supposed to check out the new tag. But when it comes to this distributed version controlling system, right, you're getting entire repository, cloning of like an image of a system, okay, into your local machine. So there is nothing like what do you call multiple times you have to check out. It's a one-time checkout. Okay, next time onwards you'll just keep update your local repository. That's it. Okay, and also there's one more benefit. Okay, these are all the benefits. There is one, not a limitation, it's a kind of a disadvantage. Okay, you cannot download or check out a single file or directory or branch, anything. You cannot get a single one because as I told you in the beginning itself, it gets entire clone of it. So you cannot get a single one from your main repository. Okay, and this is suitable for lean, or I would say small repos. Okay, small code bases. Okay, so what exactly I mean small code bases is, you try to keep your source code as much as less size. Okay, don't keep it in gigabytes or terabytes and all. Okay, so try to keep it in some MBs. That's it. Okay, maybe maximum of 100 MB, 200 MB, 500 MB, not more than that. So for those kind of systems, this distributed version control system work much better. Okay, but when it comes to S3N, right, you can keep gigabytes as well. Nobody will download entire S3N repository, right? People will download only the required one. But here, when it comes to here, right, if you try to maintain a 20 gigabytes repository, so everybody when they're cloning it, 20 gigabytes downloading in nothing, it takes a lot of time. So don't keep more than 1 GB of your source code in your Git repository. So try to make smaller repositories. Okay, make many smaller repos. Okay, but in S3N they make one bigger repository, okay, but when it comes to distributed version controlling systems, you try to make many smaller repos, so it is easy to work and easy to maintain as well. Okay, so these are all the features of distributed version controlling system. Now when it comes to what are all the tools will support DVCS, okay, the most popular tool is a Git, okay, and a Mercurial and Bazaar. Okay, guys, anyone know any other tools? These are I worked on, I'm aware of it, but there are few more tools are there. Okay, so among them, as you know, the most popular tool, if you go to the Google and type version controlling system or distributed version control system, you will get the Git. Okay, you can just try it out here. Distributed VCS. Yeah, a distributed VCS. Can you see this? You have an entire explanation of it, helps to isolate the changes between the the other one is a centralized system. That was a SVN actually. Okay, so go to the Wikipedia, you can find okay, yeah, Git is there, but I'm just looking for the exact tools. Yeah, Git is an open source and DVCS tool, okay, developed by the Linux kernel guys. Okay, so SVN is a server centric version controlling system, right? So similarly, you just Google it, you can find most of the few tools so you can see GNU Bazaar. This is also distributed version controlling system. And Mercurial, yeah, this is also Mercurial, we also call it the HG. Okay, so these are all DVCS tools. Now among them, let's see the Git now. Okay, so this Git is a version controlling system, and the Git anybody can use it. They can just download and install and they can use it. But the thing is, when it comes to our point of view, we need to maintain a remote repository. Okay, so to maintain a remote repository, the Git doesn't have any kind of a what do you call feature to expose to the external machines. Same concept again. Okay, when it comes to SVN, right, if you remember, we have a SVN server. Okay, but SVN server doesn't have a capability to expose to the external world, and it doesn't support any kind of a security features and all. So to make the SVN more sophisticated, as well as more comfortable to the developers to access the SVN repository, right, we introduced a middle layer called Apache repository, right? Apache web server, Apache web server. So with the help of that, we should be able to connect to the SVN server and we can authenticate, authorize and all. Same concept over here. Even the Git repository, once you create in one of the server, people cannot clone from that. Okay, you have to provide a medium nothing but which you should provide an option to people to access your repository with the help of this. So that layer, okay, you can host any of the web servers and all, but instead of that, in the market, right, we have n number of tools. Those guys are providing nice medium or nice user interface for the developers to get the remote repository to the local, and they can push it and they can see all the history and they can see everything on a user interface. Okay, so we have n number of providers. So those people we call as a providers. Okay, so we have a number of providers in the market. Bitbucket is the most popular one from Atlassian company, and this Bitbucket earlier used to call as a stash. And then apart from that, there is a GitLab, and there is a Bitnami. Okay, Bitnami Git, and what else? Yeah, these are some on-premises solutions, guys. What do you mean by on-premises solutions is, see, the Git repository, either you can host on your data center, okay, on-premises nothing but your own data center or your own server room, you can call it as, okay, your own data center, right? So, and one more is cloud-based. So suppose we are such a big company, we have 1,000 developers out there, and we have a data center is available, we have a number of servers out there. If that is the case, what I can do, I can choose any one of the server, I can set up any one of the server and allow my developers to access it. That type of system. Now whatever you did it with the help of the Bitnami, right? Sorry, it's not Bitnami, guys, it's, what is it, Gitblit. Okay, Git. Okay, so whatever you did with the Bitnami, right, the Bitnami is on-premises solution where you will install it on your own server and you access it, right? Those solutions are called the on-premises solutions. Now there is one more solution is available in the market, which is the cloud-based. Okay, so the cloud-based solution is you don't require any data center or any server or like any software. Okay, you have a PC with a browser and internet is enough. Okay, if you have internet, that's enough. Okay, there are n number of providers are there in the cloud. They will allow you to create the repositories, and those repositories can be accessed by the multiple people. Everything, the backend work is taken care with those guys, and the most popular one is the GitHub, github.com. So the this company, this provider, like GitHub provider, so this guy is providing n number of public repositories. You can create it in case if you want, you can create the private repositories as well. Okay, so just you need to sign up, just like how do you sign up your Facebook page and all, something like that. I already have an account here, guys. I'm just trying to sign up. That's it. I logged in now, and creating a repository is pretty easy for me. I don't need to have any Linux server or Windows server and so many installations. If nothing is required, if it is a cloud, you just need to have some internet connection. That's it. Okay. Now I logged in over here. Creating a repository is pretty easy. It's completely graphical user interface. Can you see new repository? Just create it here. So I would say DevOps Chan. Okay. A repository, I'm creating it in my account, and there are two types of repository you can create: public and private. What do you mean by public and private is? See, public nothing but once you create a repository, anybody can see. See, as it is hosted on the internet in the cloud, right? Anybody can access it, right? So typically we don't want the public repo because we wanted to keep our source code secure, right? So if you want to keep source code secure, go for the private. But only thing is, if you want to go for the private, be ready with your money. Okay, you need to provide your credit card details and all. Okay, so I'm not going to create any kind of a private now, but the repository is same, guys. Only thing is, this is visible to everyone, this is not visible to everyone, only to you. Okay, so I'm trying to create with a public repository at the moment. Okay, and initialize the repository with readme. You remember when you created a SVN repository, it created a readme file and committed with revision number 1 and gave it to you, right? Similarly, if you try to select this, it will create an empty file and commit in your Git repository and give it to you. Just create a repository now. That's it. Can you see this? Your repository is ready now. Okay, your readme file is also created, a simple readme file. Nothing is there in the readme file. Okay, your repository name is DevOps John. Okay, now this is what your repository is ready now. Now it's your job to come to the client side. Same architecture, guys. Now my repository is ready. Only thing is, which is there in the GitHub. Okay, in GitHub my repository is there. Okay, now my job is to into my machine. Okay, I have to download that repository and I need to work and push it back to my repository. So to download that and to work on my machine, I would need Git Client, just like an SVN client how you install over here. If you remember the SVN session, we install the SVN client over here, right? So similarly, we need to install Git Client. Okay, so let's try to download the Git Client in our machine and clone that. Git download. Say Git download in the Google. You'll redirect it to this site, git-scm. So this is what the site. So your client can be anything. It can be Mac or Windows, Linux, or else who's the machine. So just try to download that and install it. Guys, in my machine, I have already downloaded this. Okay, if I click this, it will just try to download as a file, and you just exe file. Just double click, next. That's it. So when you complete your Git installation, right, client installation, go to your start menu, type Git, you search it in your menu. Can you see Git bash kind of a prompt you see it? Okay, so try to open this Git bash. This is what your client. Okay, you will be working over here. This is not like an SVN, guys. Okay, in SVN you open existing command prompt, you type SVN command. Okay, but when it comes to Git, right, Git is separately providing a prompt to you. This is a Git command prompt actually. Okay, and you can work all your Git commands over here without any issues. Right, now you can run a command called git-version, maybe hyphen version. Yeah, I have downloaded 2.8.1. What is there at the moment? 2.11. So I have a little bit older one, but anything is fine. Okay, so once you have the git command available, or the git bash is available, right? So what you're supposed to do to clone your repository from GitHub, it's pretty simple. Can you see clone here or download? This guy will give you a nice URL to you. Okay, copy this URL, Control C, and simply come over here, git clone, okay, and paste. That's it. It is cloning the repository from the your GitHub to your local now. It's successfully cloned. If you really want to cross check, you can check it out. Can you see DevOps John, DevOps John, and get into that? Can you see readme file? That's it. It's pretty straightforward. See, within few seconds or few minutes, we completed the repository setup and we cloned it, and we can now perform the operations as well. Okay, like committing it and pushing it, all those stuff. Okay, so that's with the cloud-based hosting. Okay, cloud-based. GitHub is the most popular one, and Bitbucket. Okay, you might be thinking you already written Bitbucket over here, right? Yes, Atlassian is providing on-premises. On-premises nothing but they are providing a server to install on your own server, as well as they have a cloud one as well. Okay, you can make use of cloud one as well. So I can show you a Bitbucket URL. Yeah, Bitbucket.org. Can you see this? Bitbucket, the Git solution. This is a paid one, guys. Okay, so you can get a free one for 1 month or something, but typically it's a paid one. So Bitbucket solution, just sign up and start working on creating the things. That's it. Okay, fine. Now my aim is to not to explain you the cloud stuff. I wanted to explain you one of the on-premises ones, so that in case if you join any organization where they are maintaining their own Git server internally, okay, within their data center, you should be able to manage it. So for that, I'm going to take a good example of Git server, very lightweight one, nice one. So let's try to download the Git one. There are many are there. Okay, so but the process is same. Git download. Go to the Git Okay, you have it for Windows, Linux, blah blah blah, everything. So what I will do it, the Linux one, I'm not sure whether this is working properly or not. Okay, but I can check it out. Let's see. Okay, it's downloading. Now what I will do, copy this, copy link address. Where is my Linux machine? Here is my Linux machine. Okay, so as you guys know, wget is a command. Just provide the link, it will download it in your Linux machine. It's downloading it. Any questions still here? Any questions? Guys, can you hear me? Mahendra, Kiran, Shashi, Vamshi.
No questions.
Okay.
Yeah, okay.
Okay, so just give me some. Okay, let me stop this. We are already downloading the Linux. Why do we need to over here? Stop download over here. Cancel. Okay. Where am I? At least it will go a bit faster. I have a question for you. Oh, once I push to remote and I want to modify the data, how it will be done? Yeah, we'll see. Like, I'll explain all the stuff, how to push the code, how to modify and all. Okay. Let this complete first. Meanwhile, what I can do it, instead of waiting for this to complete, we can download the WAR file as well. So setting up with the WAR file is pretty easy actually. Why I'm downloading again? Downloads, cancel, get right to WAR. It is 37 MB and this is 40 MB. It shouldn't take much time. Yes, Linux is a distributed version control install multi what do you call it? Yeah, distributed, right? So you can open a number of sessions. I'm trying to open a duplicate session of the same Linux machine. Vagrant. So you can open a number of sessions. Now what I will do, I will try to install something else. Java 7. Okay, so this is to install Java on your Linux machine. The reason why I'm installing Java 7 is if the other workaround, this won't work, right? I can try it out with the application server Tomcat and host the WAR file, because that's the reason I'm downloading the WAR file over here. Let's see which one works better. You can follow anyway, any one of it. Okay, multiple installs are there. You can follow any one of it. Okay, this is 54%. Come on, quick. Okay, meanwhile, what I can do it until this completes, I can cover some client share commands. Okay, so let it go on. Now, Git Client. Okay, so this you need to download from the Git SCM site. Okay, git-scm.com. Okay, now once you download this, right, you should be able to find Git Bash on your start menu. Okay, so try to open that. It will open a $prompt session. Okay, then here you can start working on Git clone your remote repo URL. Okay, then get into your repository. Okay, get into your repository. So once you get into your repository, you can make use of all the, like, you know, if you remember the svn commands, right? Pretty much all the commands are same as svn commands only. Get status. which will show you like which status you are there exactly. Okay, and similarly git add, if you want to add any file, git add. Okay, and if you want to commit anything, okay, git commit. Now you might be having a question. Now same syntax guys, instead of string you put git. So you might be having a question over here, what do you mean by git commit? So when you say git commit, right, okay, you are trying to commit from your local workspace to your local repository. Okay, so this is called git commit. From workspace to repository you are trying to commit. Then how do I send the local repository or my remote repository? So that operation we call it as a git push. Okay, so sending your local repository to remote repository, that we call as a git push. Now similarly, to download the remote repository changes into the local repository, that operation we call it as a git pull. Okay, then if you don't even have a repository, assume like you don't even have a local repository, assume like you don't even have a local repository. Okay, in this case, okay, you try to get a you try to create a local repository. This operation we call it as a git clone. That's what we did, right? We don't even have anything over here, so we ran a command called git clone, so it created a local repository in my local machine. Okay, so local repository by getting your remote repository from your GitHub or whosoever it is. See, this can be cloud or on-premises, doesn't matter for me. Okay, so I have a URL, I just cloned it and it prepared my local repository. So these are the important 4 or 5 commands, guys. Simple commands: git clone, git status, git add, git commit, and git push. If you know these commands, right, you're pretty much like done with the git client stuff. Actually, the basic stuff actually I'm talking about. Okay, where am I? This is still going on. This is 83%. Okay, okay, this seems to be asking a question. Yes, let's see which one completes first, so that that we'll use it to host the GitBlade server. %91%. I think the Java might take some time because it's almost needs to download 180 MB something around. So 61, almost 61, it is completed 6 packages, so we can try with this one itself. But let it go on in the backend because future we need the Java as well in our Linux machine. Okay, cool. So this is completed, the Linux installer. So what is the installer name? Gitblade. Okay, it's not an installer, guys, it's a tar file. Okay, zip file actually. So the zip file you can unzip it with the help of a tar-zxuf command. Just put this, it will try to extract it. Now it is successfully extracted and you can get into the directory. You should be able to find some installer file over here. Okay, so otherwise we can look at some document which will show you how to install it. Okay, documentation, how we are going, not a war file, we are going through server configuration. Did you see installation doc anywhere? Git setup go. Okay, so if it is a Linux, it's downloading, it's no. So what you are supposed to do is data gitblade. There should be a file actually which starts the server. Okay, This seems to be a lengthier process. No, this will take more time. Again, this guy is saying like, we need a Java for even for this way. No, this is not the one. Let me look at over here. Git.sh command not. Oh, okay, so it requires Java, guys. Java command not found. So we need to wait for Java to be completed. There's no other way. Okay, so let it go on. Java is mandatory to set up this Git server, whether you go with the var or whether you go with this installer. Okay. Meanwhile, instead of wasting the time, what I can do it, I can show you the commands of Git, this Git Client commands with the help of GitHub. Okay, because we already created a repository here. See, it doesn't matter whether it is a cloud or on-premises, right? So let's try to do some sort of operations. I cloned a DevOps one. Okay, let's try to create a new file. Hello.txt. Now look at this Git status. Can you see a new file has been created? Hello.txt. Okay, so before that, pushing or adding a file and all, what we are supposed to do, we need to set up our username password, guys. Git config -- global user.name. So my name is already set here because in case if you try to install your Git, right, your name might not be set over in your Git environment, but you need to set up that. Okay, so look at this. I'm just trying to set up my name again with instead of Chiranjeevi Patel, Chiranjeevi P. Now you try to run this. Can you see it's been changed to now Chiranjeevi? Okay, so now similarly email. So my email is like, my official email ID is there. Okay, I can update this with chiranjeevi.patel@gmail.com, something like this. Okay, now you check it out email. See, Gmail is there, right? So once you set up that, then you need to start with the Git commands actually. Now look at the Git status. Can you see Git status hello.txt? Okay, now look at the steps, how we proceed. First thing is creating steps. First thing is cloning, that we are done. Okay, now create a new file. This we are done. We created a new file. Now this file should be part of your local workspace. So for that you need to say git add hello.txt. So when you say git add hello.txt, then it is part of your local workspace. Now it is added. If you really want to cross check whether it is added or not, run git status. Can you see it become green color and it says like, it's a staged file. Okay, I'll explain you what do you mean by staged file. Now it is added. So once this is added, don't think like, if it is added, it's been pushed to your it's been committed to your local repository. It is not even committed to your local repository yet. We need to make you run a command called git commit -m my first commit hello.txt. You can write anything. Now it is committed to your local repository, guys. Okay, so if you look at the architecture diagram, it is now committed to your local repository. Now your file is there in your local repository here. Your file exists over here now. Okay, now once that is done, okay, now you come back here and try to refresh your GitHub cloud. Can you see any file here? Only readme is there, nothing is there. Now to send your changes to your remote repository, we will make use of a command called git push git commit -m my first commit with git push. Okay, done. Yep, successfully pushed. Now come back to your, guys, it is successfully pushed. Can you see this? Come back to your browser and try to refresh in cloud. Can you see hello.txt? Who committed? Myself, Chiranjeevi, my first commit. Can you see a log message here? Okay, so this is what hello.txt, and you can see the file content also. Hello I have written over here. That's it, nothing else. So this is how it works actually, Git. Just like an instance. See, once you know one version control system, learning others is pretty easy. So the concept is same. Okay, now instead of this cloud one, I need to show you the on-premises one. Like, this entire setup we need to do it on our local server, right? That's what I'm waiting for this to be completed. Okay, Java is completed. Now what I can do on this, Can you see? Once Java is up, this command is running fine. Without Java, it will not work. Okay. So there is some issue actually. I think that it's a port issue. I can see that over here. There is an exception. I understand why the exception. My Bitnami SVN, if you remember, till yesterday we are working on Bitnami SVN, that is running on port number 8080. Okay, if you look at the status, it is running actually. So even the Git also works on same port number. So two processes cannot sit on same port. So that's the reason I need to stop my SVN first. Okay, I'm stopping my SVN subversion, and now come back to your gitblit gitblit.sh. Now run this. Still having some issue, guys. Okay, let me see what exactly the error, instead of having a glance over it. Address already in use. Could not open. Shutdown monitor on port number 8080. What is running on port number 8080? Let me cross check first of all whether this is up or not. 192.168.8080. Nothing. 8081. Oh, something. 8081 something is running, guys. Some cluster on Aerospike. Okay, got it. The VM which you download from this company, this organization only, Aerospike. Okay, so let's change the port. 8081 we need to change. Okay, there should be a 8081, right? Star. I'm searching which file it contains the port number, so now we can change that. Yeah, got it. So data default properties. Here shutdown port is 8081. So let's try to change that. Shift insert. Where is 8081? Here it is. Let's make something else other than that. Delete. Let's make it as 8088. Right? Now you start your gitblit.sh. Okay, no error now at this point of time. Cool. Okay, it seems to be started. It should be worked on 8080, not subversion, guys. Remove the subversion. Just say port number 8080. Enter. No. No. Sorry. Remove this. Okay. Gitblit. Okay. Let's see what exactly the URL. He might be showing somewhere over here. Daemon is listening 9418. Shutdown port 8088. But what is the exact port? Is it the same? No. Let's check it out. What exactly the port is saying. This is shutdown port. What is opening port? Gitblit. Let's see HTTP. It should be HTTP port actually. Somewhere we should be able to find it out. HTTP proxy, plugins, host, plugins. No. One second. Grab 8080 star minus R. Okay. Yeah. Open your browser to this. Yeah, localhost. Yeah, this is what we are doing it. 8080. Which file it contains? This one. This seems to be such a big one. Okay. Are we giving the right IP? 192.168.33.10. Let me check. ifconfig 192. Okay, this is right. Colon 8080. Okay, let's try to start one more time. No plugins. No. There should be a port number actually. Port. Let's search with the port. Mail.port is there. SMTP port is there. Okay, server HTTP port. This is 0. I think with this we can set it up. What we'll do, we'll set up with 8080. Okay. Now we'll start. Get pledge.sh. Yeah, now it is, I think, HTTP port it is setting it up. Yeah, 8080. Now we can check it out. Yes, the site is up, guys. Your Git internal Git hosting portal is ready now. Okay, it's pretty simple website. There's nothing over there. It just hosts the repositories. Your job is to log in as an admin. So the default username password for admin is admin guys. Now I logged in as an admin. Okay, now you can check it out, my username admin, and if you want you can change the password as well. Go to the my profile and just change your password, repositories and all. So it's a kind of a self-explanatory. There is nothing techie thing over there here. Self-explanatory. Now once you logged in, right, can you go to the repository section and create a repository? That's it. It's like a completely user-friendly, like how you did it in the GitHub, right? Similarly. So DevOps, right? I just created a new repository called DevOps and say practice some description, practicing Git. Okay, and concept is same. Include readme file if you want to include it, and don't select anything else. Just directly go ahead with readme. That's it. A repository has been created, guys. And if you wanted to know the repository URL, can you see the URL here? See, the look and feel is different, but the concept is same. You need to go for the HTTP URL, guys. Copy this. I'll tell you I'll explain you why SSH is also there. But for right now, choose the HTTP URL. Just choose that. Okay. Now you can start cloning the repository. Just come over to your Git client and come out from this one. C colon DevOps mkdir Git practice. Okay. Get into Git practice. Git clone. Paste it. That's it. It's cloned now successfully without any issues, right? So now the concept is same. Again, get into the DevOps folder. Okay, and you have a readme file. You create a file, you commit, you add, you push it. Okay, and you can see those files here, right? Right now you have only the readme file, but you can see the rest of files. If you click on tree section, you can find the files. What are all the files over there? Okay, guys, did you feel it easy or tough setting up the Git repository and working on it? Working on the client stuff is pretty much same like SVN only. There's not much difference. Were you able to follow? There? Anyone? Guys, anyone is there? Yes,
Yes,
Shashi.
yeah, it's clear.
Okay, cool. Yeah. So now the next step is to, like, the server side is done, the repository is ready. I showed you two ways. One is cloud, one is on premises. Okay. Now the second stuff is working at the client side. Okay. From the client point of view, from the client side, right, these are the very basic commands. You must and should know all these commands. But apart from that, okay, we have, like, few more git commands. Okay, so we should know all these git commands. Again, we should know how we do the branching. Okay, how do we do the merging? Okay, how do we do the tagging? Okay, and there's some git concept like, cherry picking, and uh, patching. Okay, so the git specific things and stashing. So all these concepts will be there further. Okay, so we will see all of them one by one from tomorrow. Okay, so guys, tomorrow Saturday, I'm going to take it little early for you. So like last week, it's 9 o'clock, 9 p.m. IST, IST time, guys. Okay, 9 p.m. IST. Any concerns for anyone? 9 p.m. IST tomorrow. Any issues? You're available, right, on 9 p.m. 9 p.m. IST.
Yeah.
Yes.
Okay, fine. So tomorrow 9 p.m. IST, I'll take at least 1.5 hours. Okay. Yeah, something you're saying, Kiran?
Yeah, I'm fine with the timing.
Okay, fine. Okay, thank you so much, guys. I'll upload this recording and video, this document as well. So please try to, like, set up the Git as well. We'll continue the session tomorrow. Thank you, guys.